Hello and welcome to MATLAB programming for numerical computations. We are at the end of module 1. In this module we are covering introduction to MATLAB programming. In lecture 1.5 we are going to cover plotting and outputs using MATLAB. Okay. Okay. We have seen various forms of output in the first 4 lectures of this particular module, and what we have seen is that when we do not end a particular line with a semicolon, the variables will echo on the screen. Okay. So, that is one way of displaying on the screen. The other way that we had used in the previous lecture was to use the command called DISP or display. Okay. So, that is the displaying on the screen that we are going to cover in this lecture. I am also going to cover how to plot the data using what is known as the plot command. Okay. For more help on plotting, we can go to MATLAB website called using basic plotting functions, the link for which is given over here. So, let us now focus our attention to displaying on the screen, and these are the various examples that we have taken on how to display on the screen. The first one is when you give a command b equal to 1271 with a semicolon, there will not be any echo, but if you do not give this trailing semicolon, this particular result will be displayed on the screen. This is what we have seen in lecture 1.1 as well as multiple times. The other way to display is using the command DISP display. It is going to display the contents of this variable b, okay, on the screen. The third way is to use display using a more advanced version of it, and display can be used in order to display certain text, such as DISP hello world will display this particular text on the screen. Okay. And that idea can be used to make a more beautiful output. So, let us go to MATLAB and look at this. Okay. Yeah. Okay. So, we have this b equal to 17 say 13, close this and press enter. I am going to get this as an echo. Okay. This is what we have seen multiple times. The same thing, if I am going to give disp b, it is going to display the contents of b, but it is not going to give the initial part, that is b equal to part that we see over here. So, when I click on disp b and press enter, this is what I am going to see. Okay. Likewise, if I give disp hello world, it is going to display that string as it is. Okay. So, it displays the string hello world. Okay. If we recall what we had done in the previous lecture using my factorial, this is what I had shown as a way to display the factorial value. Okay. What does that do? Let me just copy this, okay, and paste it over here, and let us go over each of this. Okay. So, this uses basically the same rules as we do with respect to brackets. The innermost bracket is what is going to be executed first. So, this is the innermost bracket, and let us look at that. Let us remove rest of this stuff and let us look at it. This is the innermost bracket. So, this particular guy is a string that says factorial value colon space, and this is a command which says num to str my fact. Okay. So, let us look at what num to str does, and for that we will do help num to str. Okay. Num to str converts a number into a string. So, let us look at what say num to, let us say my fact equal to say 6 factorial. So, we can do that using prod 1 to 6, and that gives the value my fact as 720. Because I did not end this command with a semicolon, I got the result my fact equal to 720. Okay. What happens if I give, let me just clear the screen, CLC, okay, num to str my fact. If I give this command, let us see what happens. Okay. What happens is again ans equal to 720. So, how does this ANS differ from myFact? Let us look at the workspace over here. The ANS that you see over here is a string, that we know that it is a string because it has this apostrophes, this slash signs in the front and the back, which means this is not a number 720, but it consists of 3 characters. The first character is 7, second character is 2 and third character is 0. Okay. So, that is the difference between ANS and myFact. Okay. Let us look again at that particular display command. I have Control C, Control V that display command, and let us look at the innermost bracket of that display command as we had done earlier. So, now we have this square bracket which has one part of the string and then we are catenating the others part of the string. Okay. Let us look at a similar thing again. Let us say part 1, that is the first part, and we say part 2, and let us see what happens. Okay. What we should get is the words PART space 1 PART space 2, there is no space between 1 and P of the second part. That is what result we expect. Press enter and that is exactly what we get. Okay. So, now if we were to replace part 2 with this ANS value, which is 720, and we were to replace part 1 with factorial value equal to this, what we are going to get is this factorial value colon space, okay, and 720, okay, that is also in the slashes because this is a string. When I press enter, I am going to get factorial value 720. Okay. So, what I want to do is replace that 720 with myFact. If I do this, if I just replace it with myFact, what I am going to get is I am trying to take a string and next to the string I am trying to put a number. Okay. When I try to do that, what I get is I do not get anything over here because that number is not converted into ASCII characters 720. I am just getting factorial value colon followed by some kind of a character that you probably cannot see over here. Okay. So, instead what we need to do is use the num to str command to convert 720 into 720 as 3 characters, and when I do that I am going to get factorial value colon 720. Okay. Now, I did not want this ANS to be displayed like this. In order to do that, I am going to give a command which says DISP, and in circular brackets when I give this, I am just going to get factorial value 720 without this ANS equal to factorial value 720. I will just clear the screen and type this again. When I give this DISP factorial value colon num to str myFact and I press enter, this is just displayed as is on the screen. So, that is what the DISP function is going to do for us. Okay. So, a more beautiful output can be created by using DISP and using num to str. Okay. Sometimes we want to type out more complex things, we want to output more complex things on the screen, and for that we want to use a function called fprintf. The syntax for fprintf is similar to what we follow in C. Okay. However, in this particular lecture series we are not going to cover fprintf. For all our purposes in this particular lecture series, the disp function is going to be sufficient. However, for the sake of completeness, I have given the more advanced output using fprintf as well. Okay. So, that covers the outputting on the screen part. Let us now look at how to plot. Okay. So, we will consider the example of the ball thrown vertically upwards. We will plot location versus time, we will label the axis, and we will go over some of the more other features of plotting. Okay. So, let us go back to MATLAB, and the function that we are going to use to plot is a function called plot plot. So, let us look at help for this, help plot, and this is what we are going to get. Okay. For now, let us ignore the overloaded method part, that is not of a concern for us right now. Let us go right at the top, and what does plot do? Plot plots a linear plot. Plot x comma y plots vector y versus vector x. If x or y is a matrix, then the vector is plotted against rows or columns of the matrix, whichever line up. Okay. So, plot is a very powerful way of plotting things. Okay. So, plot x comma y is going to plot y as a function of x. Okay. Let us take that example that we had done a couple of lectures earlier, which is of ball being thrown vertically upwards. This was the script that we had used for the ball that was being thrown vertically upwards. Okay. When we run this particular script, what we got was we were getting this display at multiple times. Okay. Recall what we have just done a couple of minutes back when we talked about the disp command, and when we use the disp command using multiple num to str, the result that we are going to get is as we can show in the screen. Okay. At various time we are getting the values of the location where the ball is. Okay. So, now what we want to do is we want to capture all of this in two vectors. Let us call these two vectors time and location. So, time equal to, let us make this a blank vector, location equal to again a blank vector. Okay. Or let us actually put this as time equal to 0 and location equal to 0, because that is what we are starting off with. Okay. And at end of this we will put time equal to time semicolon t. What that is going to do is at each time this while loop runs, the new value of time t is going to be catenated to this time vector time, and likewise we will do location equal to location colon y. Okay. And finally, we want to plot this, and we will give the command plot time comma location, enter semicolon, save this. Okay. And we execute this. We will clear the screen first, and we will just execute ball vertical, and this is going to plot. Okay. So, this is the trajectory of that particular ball as the ball goes from time 0 to time 4. Okay. Now, what we want to do is we want to label these two axes. The x axis is time, the y axis is location. We do that, the x axis we will label it by using the command x label time, and time was in seconds, enter, and y label location, and location was in meters. Okay. And let us go to that figure again, and now we see that this has been labeled time and it has been labeled location. Now, let us say that we want to increase the font sizes of this. The way to do that is click on this arrow, right click, click on font, and we will be able to increase this font size to 14. Likewise, we will increase this font size again to 14. And we can do this with the axis as well. We click on font and make this font size 14, and we will get this particular figure, and we now have the font size increased to 14. Okay. Now, there are options to change the way this particular line is displayed also, and the way to do that is again using the plot command, plot Okay. So, this can be done again by using the plot command, and way to do this is give plot our time comma location comma give MATLAB how to plot this, and for example, we wanted a dashed line which is red in color, we will give dash dash r, that will plot a red dashed line, okay. And let us go and see this, okay. And what we now have is a red dashed line as seen over here. Now, instead if we wanted to have a dash dot line which is green in color, we will change it to dash dot g, and that will plot a line that is green dash dotted in color, okay. Instead, now if we wanted, in addition to that, we also wanted, let us say, to plot circles at the end of it, a blue color line with circles for at the various locations, we will do dash b followed by O, and O will tell MATLAB that at each data point we want to have a marker that is circle. Press this enter and let us see what happens. At each data point we now have the circle plotted as seen over here, okay. We can also change the size or thickness of this line. Again, by right clicking this line styles, we have different styles of lines, as well as line width we can change this, let us say, to line width of 2.0. Again, this markers, we can change the markers to different types of markers. We have plus sign, circle, star, square, diamond, and so on. So if we wanted, let us say, star, we can press this and we will get star and so on, okay. So these are multiple ways of one plotting and manipulating the plot, okay. Now let us say we wanted to plot multiple things on the same plot, how we can do that. So for that, let us have a value of x, let us say x equal to 0 to 5 in steps of 1, okay. And let us say now we wanted to plot sin x and cos x. So all we need to do is plot x comma sin x comma dash b, that will be a blue color line, and x comma cos x comma dash r, sorry, let us say dash dash r, that will be a red dashed line. When we do that, this is what we are going to get, okay. I actually made a mistake when I typed x. I did x in steps of 1, that is the reason why we got plot in that particular manner. If I had x equal to 0 to 0.125 and then I give the plot command, let us see what happens, and we now get a smoother plot, okay. So we now have this particular blue line and this red line, both of them are plotted on the same plot, okay. So the way to do this is, when we have multiple x and y vectors, we can have them comma separated and we will be getting multiple plots, okay. Another way to do this is also to define a matrix, let us say y equal to sin x colon cos x, okay. Let us type size of y, okay. So y has 2 rows and 51 columns, that basically means we have the first row is sin of x and the second row is cos of x, and let us say when we do plot x comma y, we are going to get plot of the 2 lines, and the 2 lines will be plotted using a default way of plotting, and the default is the first guy is going to be a red dash, a blue dash, and the second line is going to be a green dash, okay. So this is the default way of plotting using matrices rather than using vectors, okay. So you can plot multiple lines on the same plot, and let us say now we wanted to plot a third line over here, but if let us say what happens if we do plot x comma say sin x plus cos x, okay. What we will see is we will get only one single line, and that is because when we do that, the previous plot gets overwritten, and that is why we are getting a single line as seen over here, okay. If we do not want the previous plot to get overwritten, well, you need to use the command hold on, okay. So let us see how that works. I have closed that plot, let me plot x comma y again as before, okay. So these are the 2 lines, blue and green line. Now if I do not want to erase that plot, I will give command hold space on, okay. And now when I plot x comma sin x plus cos x, this is what I am going to get. Let me go to this file again. Okay. So, these were the original two lines in blue and green color, and this is the third line that got plotted in blue color. Now, let us say we actually wanted to plot this in red color. What I will do is just go click on this and delete this particular line, okay, and plot this, say using dash dash r, and that will give me a red dashed line on this figure. Okay. So, this is the way you can use the plotting commands. Okay. So, what we have done is we have looked at plotting location versus time. We have looked at ways to label the axis, we have looked at certain other plotting options, and we have seen how to plot multiple lines using matrices, as well as how to plot multiple lines using hold on. The final thing is how to plot a log-log plot. So, for that again we go to MATLAB, and we do not know how to plot a log-log plot. So, let us just do help plot and see whether we can find out how to plot log-log plot. Okay. At the end, close to the end of this help, you will see C also, okay, and C also will give you commands that are related to plot. So, there are plot tools semi-log x, semi-log y, log-log, and so on and so forth. So, log-log is probably the one that we need to use. So, let us just click on log-log and look at the help. Log-log is nothing but a log-log scale plot. Log-log works in exact same way as plot, except the scales are logarithmic. Okay. So, let us say I do log-log x comma y, I am going to have x and sin x, x and cos x on a log-log plot, and this is how I am going to get. Okay. So, what is the funny thing that has happened over here? Okay. Remember, sin x and cos x have negative values. What happened when we plotted using a log-log is that the negative data was ignored during the plotting. So, only the positive data were plotted in the log-log plot. Okay. So, what we have covered is the basic plotting functions. We have covered how to label the plot, we have covered how to plot multiple lines, how to use hold on in order to keep the previous lines. We have looked at how to change the fonts for the axis labels as well as the axis titles. We have also looked at plotting log-log plots. In the same way, we can plot semi-log plot using either semi-log x or semi-log y command. Okay. With that, we come to the end of this particular lecture and also to the end of this module. Before I end, I will quickly recap in the next minute or so what we covered in this module. So, what we covered in this module was introduction to MATLAB programming. We looked at MATLAB basics, familiarized ourselves with the MATLAB command window and MATLAB editor. We looked at variables, scalars, vectors and arrays, and became comfortable using array operations. Okay. We also looked at both scalar as well as matrix operation, A multiplied by B using A star B, as well as A dot star B, where that was an element by element multiplication. So, both of these types of mathematical operations we covered. We also covered trigonometric operations, covered operations such as sum, prod, cum sum, cum prod, and so on and so forth. So, a wide range of operations we have covered in lecture 1.2. We have also looked at arrays and used arrays to unlock the potential of MATLAB, compared array operations versus elemental operations, and used arrays for more efficiently using MATLAB. Let me finally go to a quick example for doing this. Let us consider the example of factorial. Okay. A better way of calculating the factorial, as we had seen, is rather than having all these number of lines, we can replace all of this with just a prod command, my fact equal to prod 1 colon n. That is exactly going to do what the entire function with the loop was going to do. So, I have replace that entire loop with this prod command, and when I execute this, that is my factorial I get the exact same result, but in a more efficient way. Okay. So, this was something that is one of the most important features of MATLAB, that it is able to work with arrays, and you need to be comfortable working with arrays to unlock the full potential of MATLAB. Of course, this is going to come with a lot of practice. As you get more and more used to using MATLAB, you will find you are going to use arrays in much more efficient way. We then looked at execution control, we looked at for loop, while loop. If then statements is something that we haven't exactly covered, but essentially if then statements are used when we want to compare certain condition. If that condition is met, certain commands are executed. If it is not met, then certain other commands, if there is an else statement, are executed. Again, if you do help if, you will get how to use the if then commands. And then we looked at MATLAB scripts and functions. We also in detail covered when to use scripts versus when to use functions. And finally, we looked at plotting and outputting in MATLAB. Okay. So, with that, we come to the end of the first week, we come to the end of module 1. In the next module, we are going to cover errors, error analysis and approximations in using numerical techniques. So, thank you and see you next week. Bye.